Hello everybody, welcome back to my shed-based 3D printing cabinet made of my old Tron XY or Tronxy or Tronxy as I called it in the last video. Not quite sure what I was thinking there, but anyway, this is my old Tronxy fume cabinet which I've converted into a 3D printing cabinet with my new printer, the Snapmaker J1s. So what I wanted to show you today was how I've converted my J1s native cabinet into actually a fume cabinet with an extraction system, and I've done it with using very easily available tools and materials, and I think it's about 90%, 95% effective at removing what I consider to be very nasty plastic fumes, which I have no intention of breathing in, no matter what plastic I'm printing with. Okay, so I have to say obviously that this is not a recommendation from me to you to do this. I'm an inherent hacker, I can't help myself, so I've hacked this basically to my convenience, and I just wanted to show you how I've done it. Okay, so let's start and just say that everything in this is actually reversible, because my reverse engineering is fully reversible, and I've done that because if I have to send this back or whatever, I'll need to do that. I'll have to reverse it. So I've used two main materials to seal this native cabinet. Aluminium tape here, as you can see. I've done the doors, around the windows, and some across the back, including the lid, which I'll come to in a minute. Just taping up everything that I think would actually possibly leak fumes out of the cabinet. So the other thing I've used, hopefully you can see that, I've done an awful mastic job, I admit, absolutely, with French bathroom mastic, and what I've attempted to do is seal up everything within the base of the cabinet. And in these corners here at the back, I had to unscrew the black strip there on both sides at the top to get sealant in behind them. The ones at the front, if I remember correctly, just came out. So I have got sealant right behind. I've also used some silicone grease down there as well on those shafts to try and just seal everything possible. So yes, so what I've effectively done is isolated the base cabinet from the rest of the cabinet, hopefully, with that mastic. So the aluminium tape goes up to 120 degrees, so there's no problem with that whatsoever. I'm not sure what the mastic goes up to, but it won't be experiencing any high temperature down there or any other place that I've sealed it up. So as I say, this is all reversible. What I do have to say about the aluminium tape is that I did have to use one of the 3 amigos to take this off. I did test it both on the perspex and the aluminium itself, and my 3 amigos are isopropyl alcohol, white spirit and acetone. Actually there's the 4th amigo, which is unpleasant for everything and everybody, so that's the last unofficial 4th amigo. So in this case I used the alcohol to get the aluminium tape off, and in my experiment that I did, it came off, particularly came off the perspex fine, without leaving any damage and taking the tape glue off. So that's the main two materials. Now the lid, I had a real problem with sealing this lid up, and the lid also is the main ingress and egress route for me now. I take the lid off, get in, get the print out, any servicing I need to do, I try and do that through the lid, because obviously I'm going to have to split the doors with the aluminium tape if I have to go in that way. So the lid, my temporary solution is basically I had to mastic up all of the PTFE system down here and add an additional layer of aluminium tape. The reason being is that there's a vortex of air coming up from the S in the J1s, the fan. There's a vortex of air coming straight up here and through the gap between the lid and the rest of the cabinet here, basically just vents right out. So, and also, as you probably know if you've been watching the videos about this printer, the lid is magnetic but it doesn't fully seal. So what I've had to do as a temporary option is use more silicone grease around the edges very carefully and weight it, and I'll show you what happens if you don't, well, if I don't weight it. As you can see, as soon as I take that weight off, there's a gap. So with the weight and the silicone grease, it seems to be sealing fine. So I'll just put the light back on so we can see a bit better. Okay, I've also sealed up the rear spool mounters, holders with silicone as well, to make sure that everything is not leaking air. So I've tried to think of everything. Okay, so how is the extraction system actually working? Well, we're going to have a look at that. So this is from the extraction system output is from my old Tronxy printer system that I put in, as I said earlier. I'll show you that in a minute. The cooling system I've decided to use is on a temporary basis here. Under the cardboard, I've got a 12 volt fan, 12 volt computer case fan, and what I'm doing with that is just keeping a positive pressure on this fan here. Now this is the S of the J1s, as I said, and sometimes it doesn't come on straight away when you print, so there's a possibility of fumes coming out of that. However, I did test it with smoke in the cabinet and the smoke didn't actually come out, but I have put a 12 volt fan in anyway, just to keep a positive pressure on that vent there. And also, as it happens, there's a heatsink, I believe, down there, so I'm getting a nice cooling vortex over that heatsink, and also underneath the cabinet as a whole, which I believe there are some electronics in there, particularly there's a heatsink in there, so I'm getting cool air right under the cabinet as well with that system. So I think I'll stick with that for the time being, but I might experiment with, as you can see, I've got an old Peltier system down there. I got out of a dehumidifying system, and I might put cooler air in, see what happens. Maybe, maybe not. Okay, so that's the on all the time fan input. Output, what I've done is converted my old system, as I said. You can see here, this is the 90mm, I think it is, pipe that goes out of the shed that was already in, and I've made up a connector here for the J1s. What I was going to do was put in two 50mm pipes, one for one side and the other for the other side, but I found actually that one is enough. I don't know about the balance of cooling, but it seems to be okay. My idea was to have a balanced cooling system. You can see my two 12 volt case fans in line there, and one is attached to the Inkbird and one's on all the time. The one that's on all the time is set at 6 volts, and that's enough to keep the temperature stabilised around 30 degrees at the moment, and also vent enough fumes sufficiently. So that's the exit pipe that comes through here. As you can see, I've made a exit pipe, and this is fully demountable. As you can see, I've put it in the perspex there. I've used a very good system of staples, hot staple. I used a hot staple gun that burnt through the perspex into the pipe. Excellent. Now, this isn't the original perspex. I bought some perspex from Amazon and cut out this window and then cut out the hole in it. I've still got the original perspex behind there. So still, as I said, reverse engineering, fully reversible. I haven't actually mentioned the little doohickey in American and widget in English that I'm printing there. As you can see, that's going on okay. No smells or anything like that. But I'll cover my satisfaction or otherwise with this printer in the next video. We're up to 10% of that. So the heart of this system is called an Inkbird controller. So I'll have to say that one extractor is on all the time, which happens to be this one here, and these controllers I'm using with the case fans, all three 12-volt case fans, are variable voltage. Now, computer case fans that I use quite happy running even at 3 volts. Obviously don't get much airflow with that, but you can infinitely alter the speed and variation of the extraction system with this with these simple controllers available on eBay and Amazon. Right, I mentioned the Inkbird. That's the Inkbird system I use. It's very variable and controllable. As you can see, I've set the temperature there, ideal temperature 35.6 for the cabinet. The temperature probe is just in there under that aluminium tape, right in the corner out of the way of everything. Yeah, so this Inkbird, you can set it for your ideal temperature. Well, you can see I've set it there at 35.6 as I said, and it's 24.5. So you can set this so it doesn't actually, the heating doesn't come on till this gets really cold. It's very variable, as I said. However, I'm not using the heating obviously, so there's nothing in there. To use the cooling, obviously, I would put in the plug from the extraction system, and normally if it was temperature critical what I was printing, I'd have that plug in as well, so it would the Inkbird would automatically trigger it at the temperatures I've set at. So yeah, heating's on, nothing's happening, but cooling, something will happen. And I can't remember the margin I put over 3.56. You can have a margin quite high over and above all of these temperatures before the fan kicks in, but once the fan's kicked in, or the cooling system, it will bring it back down to the ideal temperature, and depending on what the heat's like, it'll keep doing that. So very helpful system. That means I can leave the cabinet knowing that everything's fully cooling. Okay, so that's what I've built and how I've built it. And as I say, it's working very well. Still a few adjustments to do on this, but so far so good. If you enjoyed my video, please consider liking and subscribing for more. See you in the next one.